So this is kind of a preview of things that we'll be doing more in the future. It says create a table, graph, and equation to match the tile pattern below. Sketch figure 1 based on the figure 1 base sketch figure 1 based, I guess, on the pattern. So this is a typo here. This should be on the pattern. So if I'm taking a look at this, sometimes I like to spend a little bit of time just kind of looking at the figure and highlighting what's new. So as I go from figure 2 to 3, these are new tiles, right? And as I go from figure 3 to 4, these are new tiles, right? So what appears to be happening each time is I'm adding this kind of jagged block of 5 to the top of the pattern. So if I was to think, okay, these were the new patterns before, that means that what I had to start with would have, whoops, I don't want the Windows Store to open. What I would have had to start with would have been these 3 blocks here. So this I'm calling figure 1. It's just these 3 blocks. And as I move forward, each time I'm adding an additional 5 blocks. So pretty easy to generate a table here. Figure 1 had 3 blocks, figure 2 had 5 more, 8, figure 3 added 5 more, so it was at 13. Figure 4 went to, I can't add 5 to that. Yeah, I can. It's 18. Figure 5 went to 23. Figure 6 added 5 more, was at 28, etc. Yeah, and it's, I guess if I extended that pattern, I could figure out the 8th figure here. Yeah, so I guess if I just continued this pattern for this 7th and then 8th, add 5 to that, and I'm at 33, and add 5 more, I'm at 38. So this says the 8th figure will have a total of 38 blocks. And then finally it says, well, I asked for a graph. Many of you were confused by this graph. You thought that I wanted you to do like a picture of the 8th figure here with all of its blocks. And again, this is just kind of a preview of things to come. So if you gave me the graph, great. If you gave me the tile pattern, that was okay too. I did ask if you could come up with an equation, and pleasantly, many of you realized each time we were adding 5. So you knew that multiplication is used to show repeated addition. So repeatedly adding more 5s, right, is shown by 5 times x. And we started out, we actually, on the first one, we had 3 tiles. So you got to manipulate this a little bit. Because if I place a 1 in there, that gives me 5, but that's not right because I need an answer of 3. So to adjust it, I could just subtract the 2. So now you can see, you know, when I put in x as 1, it gives me an output of 3. When I put in x as 2, 5 times 2 is 10, minus 2 gives me an output of 8. So this is the equation that we were looking for. And then the final question, I guess I'll just do in this same video. I'm giving you a function. G of x is x minus 4 in parentheses. That gets squared. And I'm asking you to find g of 3, negative 2, 0, and 4. So when I plug a 3 in there, this becomes a 3 minus 4 squared, which is negative 1 squared, which is 1. So this should have been a 1. When I plug in negative 2, again, it was it would look like this: negative 2, there's my x, minus 4, and then squared, which is negative 6 that gets squared, and negative 6 times negative 6 is 36. So g of negative 2 produces a positive 36. G of 0, again, remember what the function is. It's x minus 4 quantity squared. So I'm putting in here 0 minus 4 quantity squared, which looks like negative 4 squared, which looks like positive 16. And then my final one, g of 4. If I plug the 4 in there, we're looking at 4 minus 4 squared, which is 0 squared. And 0 times 0 is 0. So g of 4 produced an output of 0. So And that was it. If there's any additional questions you have, please see me in class. Best guess is we are taking a test on this on Friday. I think it's Friday the 3rd. I'm looking at my calendar. No, Friday the 2nd of September. This is Mr. Roberts signing off.